We live in a universe defined by motion. From the firing of neurons in your brain to the orbit of the Earth around the Sun, stillness is an illusion. Everything is drifting, spinning, and rushing through the void. For thousands of years, humanity has been obsessed with going faster. We tamed the horse to conquer continents. We built the steam engine to shrink nations. We broke the sound barrier to rule the skies, and we rode rockets of fire to touch the face of the moon. But our biological senses deceive us. We think 60 miles per hour is fast. We think a fighter jet screaming across the sky is the pinnacle of velocity. But on the cosmic scale, we are statues. We are frozen in place. To the universe, our fastest rockets are nothing more than snails crawling across a razor blade. We have barely learned to crawl, yet we dream of sprinting across the galaxy. But there is a wall, a cosmic ceiling that looms over our reality, a limit so absolute that it defines the very structure of space and time. 292.458 meters per second, the speed of light. To us, living our slow, biological lives, this number is just an abstraction. It is too fast to comprehend. Consider this. In the time it takes you to snap your fingers, light has already circled the planet Earth 7.5 times. If you could drive a car to the sunset at highway speeds, it would take you 170 years. Light makes the journey in 8 minutes and 20 seconds. It is the messenger of reality. It is the speed of causality itself, the maximum speed at which one event in the universe can affect another. Think of it not just as a speed limit for travel, but as the render speed of the universe. Nothing, no signal, no gravitational wave, no matter, can outrun it. If the sun were to vanish this instant, we wouldn't know for 8 minutes. We would still see it shining, feel its gravity, and bask in its warmth, oblivious to the fact that our anchor in the cosmos was already gone. We are always living in the past, trapped by this delay. This delay creates a terrifying isolation. It means that the farther we look into space, the farther we look back in time. But it also implies that now is a purely local concept. There is no universal clock ticking for the cosmos. What is happening right now in the Andromeda Galaxy is physically impossible for us to know. The speed of light separates us from the rest of the universe not just by distance, but by a barrier of silence that can never be fully breached. But what if the laws of physics were merely suggestions? What if we could build a machine, a vessel of infinite power, that could push you right up to that limit? Not 50%, not 90%, but 99.9999% of the speed of light? What would you see? How would the universe behave? And most importantly, if you left, would you ever be able to come back? Tonight, we are going to find out. We are leaving the safety of Earth behind. We are embarking on a one-way trip through the impossible. Welcome to the speed of light. Before we ignite the engines, we have to understand why this journey is technically impossible. In 1905, Albert Einstein changed the world with a simple concept: special relativity. He discovered that space and time are not separate entities. They are woven together into a fabric called space-time, and the speed of light, symbolized as c, is the conversion factor between the two. It is the constant that holds the equation of the universe together. Here is the problem. Mass and energy are interchangeable. You know the equation, E mc2. What this means for a traveler is brutal. As you move faster, your motion energy adds to your mass. The faster you go, the heavier you get. At 10% of the speed of light, the effect is negligible. At 90%, you are twice as heavy as you were at rest. But as you inch closer to 100%, the curve spikes vertically. This is not just about weight. It is about inertia, the resistance to change in motion. As you approach C, the universe pushes back. It fights you. It demands more currency for every inch of speed you try to buy. Imagine pushing a shopping cart. Easy, right? Now imagine that for every step you take, rocks magically appear in the cart. The faster you run, the heavier the boulders that fall into it. Eventually, the cart becomes as heavy as a planet, then a star, then a galaxy. To reach the exact speed of light, your mass would become infinite. To move infinite mass, you would need infinite energy. All the energy in every star in the observable universe, every supernova, every quasar, wouldn't be enough to push a single grain of sand to the exact speed of light. This mechanism is the universe's way of protecting causality. If you could travel at light speed, or faster, you could theoretically send a message to the past. You could trigger effects before their causes. The universe prevents these paradoxes by placing an infinite energy toll booth at the speed of light. It effectively says, you can approach the horizon, but you are forbidden from crossing it. It is a mathematical firewall written into the code of reality. Only photons, particles with zero mass, can travel at this speed. To be light, you must be nothing. You must shed the very matter that makes you human. But for the sake of this journey, let's assume humanity has cracked the code. We have built a ship with an engine that can provide continuous, limitless acceleration, perhaps powered by antimatter or a black hole drive. We have shields that defy physics. We are going to cheat the universe. You strap into the pilot's seat. The systems hum to life. The countdown begins. We aren't just going to the moon. We are going to the end of time. You engage the thrusters. You don't jump to light speed instantly. If you did, the G-force would turn your body into a thin paste on the back wall of the cockpit. Biology is fragile. Instead, we will accelerate at a comfortable 1g, 9.8 meters per second squared. This is the same gravity you feel standing on Earth. It's comfortable. It feels like home. You can walk around the cabin, pour a drink, and sleep in a bed. But do not underestimate constant acceleration. It is deceptive. In the first few hours, Earth recedes behind you. It shrinks from a massive globe to a marble, and then to a bright blue star. By the end of the first few days, you are passing the orbit of Mars. After a week, you are blazing past Jupiter. The giant gas planet is a blur, its great red spot visible for only a fleeting moment before it vanishes into the dark. As you leave the giants behind, you realize something profound: the scale of the void. We often think of space as being crowded with stars, but it is mostly empty darkness. As weeks turn into months, you enter the lonely regions of the solar system. You pass the Kuiper Belt, the graveyard of frozen rocks. You pierce through the Oort cloud, the shell of comets that surrounds our sun. Here, the sun is no longer a disk. It is just the brightest star in the sky, indistinguishable from Sirius or Alpha Centauri to the naked eye. You are now truly alone. The radio signals from Earth, news, music, voices, are taking hours to reach you. Soon, they will take days, then years. The silence of the void begins to set in, and behind you, a new kind of darkness forms. It's called the Rindler Horizon. As you accelerate closer to light speed, light from Earth struggles to catch up to you. There is a point where the light emitted from Earth today will never reach your ship because you are outrunning it. You are effectively severing the causal link with your home. Information from your past is being deleted from your future. You are leaving the observable universe of Earth behind. Months pass. You are still accelerating. You are now moving at a significant fraction of the speed of light. You pass the Voyager probes, humanity's ancient messages to the stars, as if they were standing still. They are motionless statues in your rearview mirror. This is where things start to get strange. You look out the window. You expect to see the stars rushing past you like lines on a highway, just like in the movies. But the movies lied to you. As you approach 50% of light speed, the view doesn't stretch. It shifts. It's called the Doppler effect. You experience this on Earth with sound. When an ambulance races toward you, the sound waves are compressed, creating a high pitch. When it drives away, the waves stretch out, creating a low pitch. Light behaves the same way. Light is a wave. As you race toward the stars in front of you, you are slamming into their light waves harder and faster. The waves get compressed. The yellow stars ahead turn green. Then they turn blue. Then, a violent, piercing violet. This transformation isn't just visual, it is energetic. The gentle warmth of starlight is transforming into a searing bath of high-energy radiation. Eventually, the stars ahead of you disappear from your vision entirely. Their light has been shifted out of the visible spectrum and into ultraviolet, and then into X-rays. Behind you, the opposite happens. You are running away from the light of the stars in the rear. Their waves are stretched out. They turn orange, then deep red, then infrared. The universe behind you fades into blackness. You are now flying through a void, blind to the cosmos that gave you birth. We are now pushing past 90% of the speed of light. The speedometer is climbing 95%, 98%, 99%. At these speeds, a new phenomenon takes over. It's called relativistic aberration, or the searchlight effect. Imagine running in a rainstorm. Even if the rain is falling straight down, if you run fast enough, the rain seems to be hitting you from the front. The faster you run, the more horizontal the rain seems. Photons behave like that rain. As you plow through the photon field of the universe, light from the sides, and even light from slightly behind you, appears to be coming from the front. Your field of view is warping. The visual universe is shrinking. The darkness behind you expands, wrapping around the sides of your ship. It feels like the universe is closing in, hugging the hull of your vessel. All the light from the stars, galaxies, and nebulae in front of you, and to the sides of you, is being concentrated into a single, intensely bright, circular window directly ahead. And inside this tunnel, something incredible happens. Remember the cosmic microwave background? That faint, ancient glow left over from the Big Bang that fills the entire universe? Usually, it is invisible to the human eye. It's just microwaves. But now, because of your extreme speed, you have compressed those microwaves so much that they shift into the visible spectrum. You are now seeing the oldest light in existence. The echo of creation itself becomes a glowing ring of rainbow colors surrounding your destination. You are flying into the eye of God. Navigating this tunnel becomes a nightmare, because the stars aren't where they appear to be. You are flying towards an optical illusion. If you tried to steer based on what you see, you would be lost instantly. You have to trust your instruments, trusting the math over your own eyes. The sheer brightness contrast, absolute blackness surrounding a pinprick of infinite brilliance, would be psychologically destabilizing. It is a view that the human brain evolved on the African savannas was never meant to process. You are no longer looking at a sky full of stars. You are looking into a blinding, concentrated tunnel of radiation. It is beautiful, and it is terrifying. This disk of light contains the energy of 1 billion stars, shifted into high-energy gamma rays. Without your magical shields, this view would cook you alive in nanoseconds. Even the colors you see are lies. Your brain is trying to interpret wavelengths it was never designed to process. The center of the tunnel is likely a white so pure and intense that it would look like a hole in reality. The edges would bleed into colors that don't exist on any artist's palette on Earth. It is a psychedelic kaleidoscope created by the bending of physics itself. But there is another distortion happening here. If you could see a passing object, say, a rogue planet, it wouldn't just look compressed. It would look rotated. This is known as Tyrrell rotation. Because light takes time to travel from the back of the object to your eye, and the object is moving so fast relative to you, you would actually see the back of the object while you are still approaching it. The laws of perspective are shattered. The geometry of your reality is twisting. But the most dangerous change isn't happening to your eyes. It's happening to your watch. Before we talk about time, we have to talk about survival. Space is often called a vacuum, but that's not entirely true. It is thin, yes, but it is not empty. There are hydrogen atoms floating between the stars. There are microscopic grains of dust. At normal rocket speeds, hitting a hydrogen atom is like a mosquito hitting a tank. It means nothing, but you are moving at 299,000 kilometers per second. At this speed, a single hydrogen atom hits your ship with the energy of a particle accelerator beam. It becomes a deadly projectile. It's not just the impact, it's the radiation. As you smash into these atoms, they shatter. The collision creates a shower of secondary radiation, Bremsstrahlung radiation, that floods the cockpit. Your DNA would be shredded before you even realized something was wrong. Your ship needs a shield, not just a metal hull, but a magnetic field stronger than a star's. You would need to project a magnetic bubble thousands of miles ahead of you to ionize and deflect these particles, creating a glowing bow shock that precedes your ship like a celestial plow. In fact, your ship would become the brightest object in the solar system for anyone watching. The friction against the thin interstellar gas would cause your shield to shine with the brilliance of a supernova. You wouldn't just be a ship, you would be a spear of light piercing the dark, leaving a trail of ionized plasma in your wake that might linger for centuries. And there is heat. You might think space is cold, but at this speed, you encounter the Unruh effect. Because you are accelerating through the vacuum quantum field, the vacuum itself begins to look like a bath of thermal radiation. Empty space actually gets hot. If you accelerate hard enough, the vacuum of space could roast you alive, not from friction with matter, but from friction with the quantum fluctuations of reality itself. And a grain of dust? A tiny speck of sand? If you hit a grain of sand at 99.9% light speed, the kinetic energy release would be equivalent to a tactical nuclear weapon. Your ship is constantly being bombarded by nuclear explosions. The empty space in front of you is a wall of death. Friction becomes real in space. The interstellar medium would heat your ship to millions of degrees. To survive this, your ship needs to be infinitely streamlined. You are not just a traveler. You are a cosmic snowplow, blazing a trail of fire through the dark. The serenity of space travel is a lie. At light speed, space is a violent, burning ocean. You have survived the radiation. You have survived the dust. Now, you face the true cost of light speed. Time dilation. Einstein taught us that time is not constant. The faster you move through space, the slower you move through time. Imagine you are driving a car on a map where the x-axis is space and the y-axis is time. You are always moving at a constant speed through space-time. If you drive only in the direction of time, you don't move in space. That's us, sitting in a chair. But if you turn the car and drive purely in the direction of space, you stop moving through time. You are now at 99.9999% of light speed. On board the ship, everything feels normal. You drink your coffee, you read a book, you sleep. Let's say you decide to visit the center of our galaxy, Sagittarius A, which is roughly 26,000 light-years away. At this extreme speed, the distance itself seems to shrink for you. This is called length contraction. To you, the journey doesn't take 26,000 years. It takes 20 years. A reasonable trip. You can do it. You spend 2 decades flying. You arrive at the galactic core, take some photos of the supermassive black hole, watch stars orbit it at breakneck speeds, and turn the ship around. You fly back. Another 20 years. For you, it has been a career, a life's work. You have aged 40 years. You are older, wiser, perhaps a bit gray. You have memories of things no other human has ever seen. You approach the solar system, expecting a hero's welcome. You imagine the parades, the press conferences, the embrace of your children. But as you decelerate, the horror sets in. The stars don't look right. The constellations have drifted. The fundamental map of the sky has changed. You hail Mission Control. Mission Control, this is Lightship 1. I have returned. Prepare for landing. Silence. Mission Control, do you copy? This is Lightship 1. Static. You land on Earth. But it is not the Earth you left. While 40 years passed for you, 52,000 years passed for Earth. The civilization that built your ship is gone. The cities you knew, New York, London, Tokyo, have eroded into dust, buried under layers of geological strata. The language you speak is a dead tongue that hasn't been heard in 50 millennia. Humanity might have evolved into something unrecognizable or extinguished itself entirely. There are no parades. There is no one left to remember why you left. This is the cruelty of simultaneity. The concept of now is a local illusion. There is no universal now. By changing your speed, you stepped out of Earth's now and into another. You broke the synchronization with the rest of your species. You traded connection for distance. You are a relic, a biological anachronism. The diseases you carry are extinct. The immunity you have is useless. Even if humans still exist, you would be a stranger to them, a primitive creature from a forgotten epoch. You have achieved immortality in a way, leaping over thousands of years. But the cost is that you can never go back to the moment you left. You are permanently displaced, a refugee from an era that no longer exists. You are not a hero returning home. You are a ghost. You have traveled to the future, but the price of admission was your entire past. Everyone you ever loved died thousands of years ago. Their graves are gone. Their names are forgotten. This is the loneliness of the photon. To travel at light speed is to be cut off from the timeline of the universe. You are an orphan in time. Let's push it further. Let's don't stop at 99.99%. Let's add more nines. 99.9% of the speed of light. At this speed, time dilation becomes exponential. You could cross the entire observable universe, 93 billion light-years, in a matter of human weeks. You witness galaxies flying by like snowflakes in a blizzard. You watch the evolution of the cosmos on fast forward. At this speed, the length contraction is so extreme that the universe itself begins to flatten. the distance between galaxies shrinks to millimeters. The entire cosmos, with all its depth and grandeur, is compressed into a thin sheet directly in front of your window. You would see the life cycle of the universe play out in minutes. Stars would ignite and burn out like fireflies in the night. Nebulae would bloom and fade. You might even witness the heat death of the universe, the moment when the last star dies and the cosmos goes dark forever. You would be a traveler at the end of time, watching the credits roll on existence itself, all while your morning coffee is still warm. This brings us to a frightening realization. If you travel fast enough, the universe doesn't just get smaller, it effectively ceases to exist as a 3D space. For a photon, the universe is two-dimensional. The dimension of depth in the direction of travel contracts to zero. If you are the photon, you are touching the star that emitted you and the eye that absorbs you at the same time. There is no in-between. The universe is a flat plane of interaction. But there is a limit. If you could actually reach 100%, the true speed of light, time would stop completely. For a photon, there is no time. From the perspective of a particle of light, the moment it is emitted from a star and the moment it hits your eye happen simultaneously. It doesn't experience distance. It doesn't experience duration. It doesn't know it has traveled for 1 billion years. To the photon, birth and death are the same instant. To be light is to be everywhere on your path at once. If you could become light, you would see the birth of the universe and the death of the universe in the same instant. You would transcend existence. You would become a geometry of pure energy, frozen in an eternal now. Slow down. Let's bring the throttle back. The stars shift back from blue to yellow. The tunnel of light widens into a familiar sky. The universe behind you reappears, unfolding from the darkness like a blooming flower. You come to a halt, drifting in the quiet dark. We can never truly travel at the speed of light. The laws of physics, the barrier of infinite mass, protect us from that fate. And perhaps that is a good thing, because speed is a trade-off. To gain the universe, you must lose your place in it. To conquer space, you must sacrifice time. To see everything, you must be part of nothing. Perhaps the only way to cheat this rule is not to go faster, but to be smarter. To warp space itself, to build wormholes, to fold the fabric of reality so we can step across the stars without paying the tax of time. But until we master that magic, we are stuck. We are creatures of the slow lane. We are bound to this rock, orbiting a mediocre star at a leisurely pace. But in our minds, we can break the limit. We can simulate the journey. We can understand the math. And in a way, that is humanity's true superpower. We don't need to be photons to see the end of the universe. We just need to be curious. We can travel faster than light through our imagination. So the next time you look up at the night sky, remember, that light hitting your eye has traveled across the chasm of time just to reach you. It has seen history. It has survived the void. And for a brief moment, as it strikes your retina, you are connected to the engine of the cosmos. The photons landing on your face right now began their journey in the fusion core of the sun thousands of years ago, fighting their way out, only to rush across the vacuum to warm your skin. They are the ancient messengers of a universe that is both violent and beautiful. And while we may never race alongside them, we can always follow where they lead. Thank you for taking this journey with us. If you want to keep exploring the cosmos, make sure to hit that subscribe button and ring the bell. The universe is vast, and we have a lot more to discover. See you in the next one.